This is section 3.2, Truth Tables, video 1. The videos for this section are not covering all of the material. The material has already been covered twice. Once in the class before spring break, and again in the module that I wrote in Canvas for section 3.2. I highly recommend reading or rereading that module in Canvas prior to watching this video, unless you already feel comfortable completing truth tables, in which case you might not even need this video. But truth tables are kind of dynamic when you're filling them out, so I felt it was good to upload a couple of examples. This video will contain the first example, the next video will contain the second. For this example, we're going to construct a truth table for the negation of a conditional, P pointing to the negation of Q. When you build a truth table, the first thing you need to do is figure out how many columns you're going to need. In order to count the number of columns, start by counting how many different letters are in the problem. In this case, there's 2 letters, and remember, these letters represent simple statements. So we're going to need 2 columns, one for P, one for Q. You'll see that I've already got those columns set up. As far as the rest of the columns, it's pretty straightforward. 1 column per connective. Technically, negation is not a connective, excuse me, because it doesn't connect 2 simple statements. But for the sake of discussion, we're going to call it a connective. This statement has 3 connectives: a negation, a conditional, and another negation. In order to build the rest of the table, we're going to have 1 column for each different connective. So we're going to end up with 3 more columns. 1, 2, 1, 2, 3. Now, don't just put the connectives on the tops of these columns. You need to figure out the correct order in which to put them, and every time you write a connective, you have to write what is on both sides of it, unless it's a negation, in which case you just have to write what's to the left of it. Now, we do have a hierarchy of logical connectives. Just a reminder that that hierarchy is something that you need to have memorized. The hierarchy of connectives is you always start by looking inside of parentheses if there are parentheses. Then you look for any negations. We have 2 in this compound statement. Which one do you think we're going to go to first? The third level in the hierarchy of logical connectives is conjunction / disjunction. Neither one takes precedence over the other. So if you see a conjunction and a disjunction side by side, you do them left to right, unless there are parentheses dictating a specific order. The 4th step in the hierarchy of logical connectives is conditional. And the 5th is biconditional. I don't know why I capitalized the C in biconditional. Most of the time, parentheses will guide you through the setup. For example, in this compound statement, we do have a set of parentheses, so we need to go inside of there first. Now, within those parentheses, there are 2 connectives. There's a conditional and there's a negation. Negation takes priority over conditional, so we're going to do this negation first. Let's determine the order, and then we'll label the rest of the columns. We're not done with the parentheses because there's still a connective in there, but it's the only one left, so it will be next. The conditional will be evaluated second. That completes ordering the connectives inside the parentheses, so now we move outside the parentheses. And there's only one connective outside the parentheses, and it's this negation. So that will happen third and last. That is the order in which we will build our columns. Now, the first connective that we're going to build a column for is this negation. So let's write that negation. Whenever you write a negation on the top of a column, you always write what is immediately to the right of it. Immediately to the right of this negation is the letter Q. So negation Q will be the third column. For the next column, go to the next connective. Second connective was this conditional. With the exception of negation, every connective has something on both sides. So whenever you write a connective, you write what is on both sides of it. To the left of this connective is statement P. To the right of this connective is the negation symbol, but that negation belongs to statement Q. So our third column is P conditional negation Q. Now that we've done the second thing in our list of connectives, let's go to the third, which is this negation. And when you write a negation, you write the thing immediately after it. The thing immediately after it is the parentheses, which means we need the parentheses and its contents. So by knowing the hierarchy of logical connectives, we can set up the rest of the columns. Again, one column for each unique letter, one column for every connective. Once you've figured out the columns, now it's time to populate the rows. To start populating the rows, we need to list every possible combination of truth values for the simple statements. In other words, every combinations of T's and F's that we can make here. In the homework and on your test, these columns will always be populated for you. For two simple statements, they will always be true, 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 false, false, true, false, false. To populate the rest of the columns in order from left to right, when you go to a column, you ask yourself two questions. What am I going to do, and which previous columns am I going to do it to? What you're going to do is dictated by the connective that you're focused on. In this case, we're focused on negation. The rule for negation is it changes a statement's truth values. So that's what we're going to do. Change some truth values. What are we going to change? Well, what's after the negation? The Q. So we're going to change the truth values for Q. That means we need to look here and change the truth values. That's pretty straightforward. This is true, so the negation is false. The negation of false is true. The negation of true is false. And the negation of false is true. Figure out what you're going to do. Figure out what you're going to do it to. For the next column, we're focusing on the conditional. The rule for conditional, and sometimes it helps to write this, the rule for conditional is false if T points to F. That's when you break a promise. If I am free tonight, then I will take you out. The only thing that can make me a liar is if I was free, the first part was true, but I didn't follow through and take you out, the second part was false. That's the rule for conditional. It's false if there's a T pointing to an F. So that's what we're going to do. What are we going to do it to? Well, look on both sides of the conditional. We have P pointing to the negation of Q. So I need to look at the P column and the negation Q column. Here's the P column, here's the negation Q column. Now be careful. Conditional is the only connective where order matters. We are pointing P to negation Q. When you're evaluating a conditional in a truth table, it's not a bad idea to draw arrows from the first column to the second column. For example, I want to draw arrows from P to negation Q. So P is this column, negation Q is that column. I'm going to draw arrows from the first column to the third column across every single row. And just for clarity, I'm going to circle all the T's and F's that I'm focusing on right now. You don't have to do any of this when you're doing a truth table, but sometimes it helps you focus. We're going to do this rule on these two columns. If we see T pointing to F, we're going to write false over here. Do you see any rows where T points to F? I only see one of them, and that would be the first row. This T is pointing to that F. Conditional is false in the first row. But that's the only T pointing to F. This is not T pointing to F, nor is this, nor is this. So none of these rows are false. That means that they're all true. Then to fill out the last column, remember we're focusing on the negation in the last column. We're going to do the negation rule, which is change the truth values, but to which previous column? To answer that, just look to the right of the negation symbol. There's a parentheses, and inside that parentheses is all that. And all of that is the fourth column. So we're going to do this rule, change the truth values to this column. Pretty easy. The negation of false is true. The negation of true is false. The negation of true is false. And the negation of true is false. That would complete the truth table. So evaluating a truth table is straightforward. You just have to stay focused. Determine the columns by first listing a column for each unique simple statement, and then one column per connective. Decide the correct order based on the hierarchy of logical connectives. And then as you fill in each column, ask yourself two questions. What am I going to do? That's determined by the connective. What am I going to do it to? That's determined by what's on the sides of the connective. If it's a negation, it's on the right side. Otherwise, it's on both sides. Be careful and you'll be able to complete any truth table.